In this video, I'll discuss topology, service discovery, and OS fingerprinting. Network intrusions always begin with reconnaissance performed by the bad guys. This includes mapping out the network layout, so how the network is laid out, and also the devices and where they are laid out within that network infrastructure. Documentation is used by the network owners and network technicians as a means of effective troubleshooting. The more we know about how a network is laid out and where things are and what their addresses are, what their names are, the better we are at troubleshooting and quickly resolving issues. But if that documentation falls into the wrong hands, it makes it very easy for them to start trying to exploit vulnerabilities that might exist. So this documentation, aside from troubleshooting, also allows the network owners and network technicians to squeeze the absolute most performance out of what they have because they can visualize where things are, how they're working, and optimize network links and network services and so on. Now, when we talk about discovering devices on a network through reconnaissance, that can happen in many, many ways. One of those ways is through a layer 2 type of discovery. Now, layer 2 of the OSI model is the data link layer, where we might be able to discover things at the hardware layer on the local network only. So things like MAC addresses come to mind when we talk about layer 2. Layer 3 discovery can go outside of the boundary of a local area network because layer 3, if you'll recall, of the OSI model is the network layer. It deals with things like routers and routing of traffic from one network to another. And at the software protocol level, it deals with things like IP addresses. SNMP is an old protocol, the Simple Network Management Protocol. And what's interesting about it is that network devices use some kind of an SNMP agent that listens on UDP port 61. Now, not every device will have this SNMP agent listening, but often it is running automatically, whether we're talking about a software appliance or even a hardware appliance on the network. Now, the agent is listening on UDP port 61. We need an SNMP server-side component that queries that SNMP agent on devices and looks through the MIBs on the device. A MIB is a management information base that contains different types of information about that specific device type. So for example, if it's a network switch, we might have a MIB that shows us how VLANs are configured, which devices are connected to which ports, how many devices are connected, amount of traffic into and out of the switch as a whole or each port, that type of information. Topology discovery, aside from SNMP, can also occur by querying centralized resources on the network like DHCP servers. DHCP servers hand out IP configuration for client devices. That would be a great way to learn about what's on a network if you can query the DHCP server and get a list of active leases and details related to that. Then there's also querying DNS servers, where we could query for many types of records, including A for IPv4 and Quad A records for IPv6, so we can learn of names of devices, names of hosts, and their corresponding IPs. Now, knowing the name of something can sometimes imply what it is. Like HR Payroll Server 1 is pretty indicative of what it is. And if we find that in DNS easily, we can also find the IP address for it. Now, ideally, you're not going to be able to find that type of information in a public DNS server on the internet, but if a malicious user can somehow get onto your internal network and query internal DNS servers, they very well could find that type of information out. So it takes one thing away from what they have to learn to get into HR payroll servers. Topology discovery can also be done by querying other types of devices like routers, where routers maintain information about network links that they're connected to. Routers also have memory, just like switches do, just like servers do, and so on. On a router, the memory is used to store routing table entries. It uses this when it receives an inbound packet from an interface to determine the best way to route it through another interface to some remote network somewhere. Then there are other routers that each router will communicate with using various protocols, like the Cisco Discovery Protocol, CDP. That's a layer 2 protocol used to discover other types of devices and information about them, specifically routers, on the same network link. Then for Juniper systems, there's Juniper Discovery Protocol, or JDP. Switches maintain information about their connected devices and how VLANs are configured. So If a malicious user can somehow do reconnaissance against a switch, maybe because there's a simple password to remotely connect to it through SSH, or heaven forbid, we're using Telnet to connect to a switch, which means an attacker simply has to capture a valid user connecting to the switch and providing the credentials, because Telnet doesn't encrypt or even encode anything. Then another way to discover items on the network is through Address Resolution Protocol cache discovery. Address Resolution Protocol, or ARP, is part of TCP/IP, and it's used to basically resolve IP addresses to hardware MAC addresses on a local area network. So it can be used to discover other active devices by looking at the ARP cache on each and every device. For example, on a Windows machine at the command prompt, I could type ARP-A to list all ARP cache entries. What we're seeing here are different interfaces. So I've got 3 interfaces listed here. I can see the IP address for the interface. I can see the IP addresses stored in the ARP cache in memory on this device, as well as the corresponding physical MAC addresses. Now, for a malicious user to do something terrible on a network, we said that part of what they have to do is learn about what's there. And this is yet another way that an attacker could learn about things like IP addresses and MAC addresses. Essentially, the more an attacker knows about our network and what things are called, what their addresses are, what they're running, what ports things are listening on, the more well equipped they are to start looking for vulnerabilities. Of course, attackers could conduct network scans if they can get on the network in the first place. They could scan for open ports to get a sense of what types of network services are out there. So for example, if they get a response on a number of devices for TCP port 80, they know that those are web servers. So they might then further their energies on those devices to see what type of web servers, and if there are any known vulnerabilities, and what version of the web server they're running, and so on. Ping sweeps can also be conducted to see what kind of a response we get on the network so we know which devices are out there. And in some cases, when you do a network scan, you might have to specify credentials. Now, this would be done by the good guys. If you're doing some kind of an audit or penetration test, or if you are just conducting a network scan of your own network, you might put in credentials that will allow you to authenticate to devices on the network and see what's running. Otherwise, the bad guys, essentially malicious users is really what we mean, would be running non-credentialed scans. Depending on how hardened your user accounts and passwords are, will determine how successful they are with a non-credentialed network scan. We'll be conducting network scans in various ways in different demonstrations in this class. You might also have an import file that already contains network topology and device information that you import, so you could see a network layout. It might be in CSV or XML format. Now, this is great for the owners of the network, but if it falls into the wrong hands, it's a problem. Service discovery can be manual, where clients are statically configured to discover various network servers. But the way things go these days is we normally have a centralized service location server. In this case, DNS could serve that role, where we've got service location records that contain hostname information and port information. This is actually what gets used by Windows devices to find Active Directory domain controllers. There are centralized service registries where network services add themselves when they initialize, and clients can discover services by querying this centralized service registry. And again, this is how DNS service location records are really treated. A directory service like Active Directory can serve as a service registry. So it's important that we secure this, since it could be a central repository of services available on the entire network. The last thing we'll mention here is operating system or OS fingerprinting. This allows us to identify a remote operating system running on a device elsewhere over the network. Now, one way this can be done is by analyzing network packets sent from a particular OS. They each have their own way of formulating certain types of packets. They put certain values in certain packet header fields. For example, the TTL, or time to live field, is part of an IP packet header. It refers to the amount of time in milliseconds before a packet is discarded or a timeout occurs. Now, there are different TTLs for different operating systems. For example, a Juniper device would use ICMP type 64 for the TTL. The Windows 7 operating system would set the TTL, the time to live, to 128. That would be the number of routers that traffic can go through, or the packet can go through rather, before it gets discarded. It gets decremented by 1 for each router it goes through. Most Linux kernels, like 2.4, would set the TTL to 255. In this video, we discussed topology, service discovery, and OS fingerprinting.